Okay, in order to use a T84 for probabilities, either the quadrant distribution or the binomial distribution, okay, the problem either is going to ask you what is the probability that x is equal to n, where n is any number, okay? Use your TI-84 and you are going to use what? The PDF, probability distribution function. Directly. Enter the parameters and then comma n, and the TI-84 is going to give you the results. What if you want to know what is the probability that x is less or equal than n? In order to do that, you don't use the PDF, you use the CDF, cumulative distribution function. And the cumulative distribution function is going to give you the probabilities for that number and below. Okay, what if I ask you why the probability of x is greater or equal than n? Remember, the CDF gives you the below, not the greater than, gives you the less than. In order to do that, you have to do 1 minus. Okay, since you are doing for the right side, you have to do the 1 minus the probability that x is less or equal than what? N is included in the greater, so n shouldn't be included in the complement, n minus 1. You see? What if I ask what is the probability of x is greater than n? In this case, n is not included in the right side, so I have to include n in the left side, in the complement, so it's equal to 1 minus p of x is less or equal than n. And again, when you have this situation, you use the CDF. Less or equal, greater, that's it. Less, oh, what if I ask you what is the probability of x is less than n? Okay? The calculator gives you the probability that x is less or equal than n. What if it's less than n? I don't want to include the n, so it has to be equal to the probability of x is less or equal than n minus 1. You see? So, and you enter that number in your calculator, and that's it. In the problem, in the test, you're going to see one of these problems. The 5, 1, 2, 3, 4, 5, the 5. You're going to see them. So be very careful on this one, and include this in your cheat sheet, so you don't forget. But you have to be logical about how to do this. I mean, it's pretty easy when you have your calculator. When you have the calculator, you can solve the problem in less than 15 seconds. So use your calculator. Right? Okay. Today we're going to cover the last part of the chapter that is about hypergeometric distribution. In the hypergeometric distribution, we have like two sets of elements. One is called success and the other is failure, or you can call it whatever you want to call it, but you have two different sets of elements. Okay? Those sets of elements are two types. I mean, I don't have 3 or 4 types, just 2 types. Success and failure. Okay? Since this is a finite, and you would say, well, this is like the binomial distribution. Well, in this case, it's a finite population. So every time that you get one element from that population, the probabilities change. Okay? The probability of getting another element change because they don't have anymore this universal or infinite number of elements like in the binomial distribution. So probabilities changes probability changes in one step to the next step to the next step to the next step. What is not in the binomial distribution. In the binomial distribution, every time, every step, the probabilities peak. But in this case, the probabilities change because we're dealing with a finite population. And we have N, capital N, that is the total population. And the total population includes the success and the failure elements, both. We have R, that is the number of successes in my sample, in my population. How many successes I have. N is my sample size, or the number of elements that I'm going to extract. And X is the number of successes that I want to get in the sample. Okay? So, and in order to and that's it. I mean, the probability of X the probability of X is equal to N minus R C N minus X R C X divided by N C N. And as you can see, these are combinations, combinations, and combinations. Mu is equal to NR divided by capital N, and sigma squared is going to be equal to NR capital N minus R divided by N squared times N minus N divided by N minus 1. That's it. That's it. I mean, that's basically the hypergeometric distribution. That's it. So let's do an example. I have a drawer, and I have socks in that drawer, and I have black and blue. Okay? I have black socks and blue socks. I have 10 blacks and 6 blue. Okay? In the morning, I wake up very early and I don't want to wake up my husband, and I'm just going to grab 2 socks, and I want to know what is the probability that I get 2 black socks. Okay? This is the perfect example for the hypergeometric distribution. We are dealing with a finite population, and I want to know what is the probability that I get a black pair of socks when I when I grab 2 random socks from the drawer. Okay? So that's it. What is the probability that I get 2 black socks? And the probability is what? What is N? Capital N is the total. The total population is 16. What is R? R is my successes. My successes in this case is the black socks. My successes is 10. Okay, N is my sample size. How many socks I'm going to get? 2. And I want my X is equal to what? To 2. I want the 2 blacks. So let's see, what is the probability that I get a black pair of socks in this situation? Okay, what is the probability that I'm going to get the 2 black socks when I go to work? Okay? So, what is the probability of 2? Guys, 2 is my X. So, N minus R, 16 minus 10 is 6 combinations, N minus X, 0. From the 6 blue, I want to choose 0. Okay, times R. From my 10 black shoes, I want to take what? 2. Divided by what? From the total population, that is 16, the combination for 2. That's it. When you enter this in your calculator, you have to use 6 combination 10 times 10 combination 2 divided by 16 combination 2, enter, and the Ch4 is going to give you the answer. Okay? Okay. 6 combination 0 is equal to 1. Okay. Always when you have 0 or whatever, it's 1. Okay. 10 combinations 2 is equal to 45. So this is equal to 45 divided by 16 combinations 2 divided by 120. The probability then is 0.375. So the probability that I get a pair of black socks when I draw 2 from the drawer is 0.375. So probably only 1/3 of the time I'm going to have my pair of black socks when I draw. Okay, so it's pretty small. And the mean is n r divided by n, and this one is this one, so that's only calculated. So don't worry about that. Right? Okay, let's do it. Mu is equal to nr divided by n, capital N is equal to 2 times r is equal to 10 divided by capital N is 16. So the mean is equal to the 20 divided by 16, 1.25. Okay, and the variance is equal to nr times n minus r n squared times n minus n divided by n minus 1 and capital N, I'm sorry. And this is n is equal to 2 times r is equal to 10 times n minus r times 16 minus 10 is 6 times n minus n is 14 divided by n squared, 16 squared, times n minus n is n minus 1 is 15. And that's it. You just enter those numbers in your calculator. 2 times 10 times 6 times 14, and then 16 squared times 15 is sigma squared is 0.4375. I think that I didn't make any mistakes. And of course, the standard deviation is the square root of this. Sigma is equal to 0.19. Okay, that's it. That's it.